Today's day 5 of Unit 9. We started today with a ticket in the door, so if you were absent, you'll need to make that up. And then we did this warm-up, so you should pause the video and try the warm-up, and then play to check your answers. Okay, so first one, selecting a card from a standard deck, probability of red or 4. Well, red and 4, those events are not mutually exclusive, so I'm going to have to add the two probabilities and then subtract the overlap. So red, that's 26 out of 52. And I'm going to add on the 4 4s. But then 2 of those 4s are red 4s, so I already counted them in the red count. So I'm going to subtract the 2 red 4s. So that makes 30 minus 2 is 28 out of 52, which simplifies to 7/13. Number 2, we roll a standard die, find the probability of odd or prime. Oh, and by the way, on that last one, if you didn't want to use the formula, just counting, there's 26, and then there's 4 4s, but I already counted 2 of them, so just add on the 2 black 4s, so that makes 28. So standard die, probability of odd or prime, I'll use the formula first. So odd would be 3/6 plus prime 2 3 5, so 3/6. And I'm going to subtract the ones that are both odd and prime. So 3 and 5 are both odd and prime, so I'm going to subtract 2/6 from that. So 6/6 minus 2/6 is 4/6. 4/6 simplifies to 2/3. So that's using the formula. Logically speaking, write out the odds, that's 1 3 5. Write out the primes, that's 2 3 5, but I already wrote 3 and 5, so just 2. So then count 4 numbers out of 6, simplifies to 2/3. Okay, so today's classwork was done on pages 15 and 16, so you'll need to refer to those pages. I'm just going to go through some of the problems on, well, all of the problems on 15, and then we got to just the first problem on page 16. So I'll do those here in the video, and then you're going to need to finish the rest of pages 15 and 16 for homework. So page 15, the first problem starts with us rolling 2 dice. One's blue and one's red, so I'm going to make myself, it says to make an area diagram. So I'm going to do that. And I'm going to separate 1 2 3 4 5 6 and 1 2 3 4 5. I'll just erase a little bit of that to make it more even. Oops. Okay. Try that again. All right, it doesn't want to erase. Well, I guess I'll just make mine a little bit uneven then. So 1 2 3 4 5 and 6. 1 2 3 4 5 and 6. So then it asks you to shade the areas where you would have a sum of 10. So that's 6 4 5 5 and 4 6. So that would be those. And then what's the probability? So this is 1. What's the probability of getting a sum of 10? Well, we just shaded 3, and each one of these is 1/36. So that makes 3/36, which simplifies to 1/12. So then part D says, suppose you know the sum is 10, but not what is on each die. What is the probability that knowing this information you rolled 2 5s? Well, there's 3 spots, and they have equal probabilities. So when they have equal probabilities, all I really have to do is say, well, count, there's 3. And of those 3, only one of them has the 5 5 combination. So the probability is going to be 1/3. Now, again, I'm able to use just logic there and counting because these have equal probabilities. If they have different probabilities, then we're going to have to do something differently, which I'll talk about here in a couple minutes. We're going to have to use a formula. But for now, they're equal probability, so I can just count and say 1 out of those 3. So we're going to move on to number 2, which again asks us to make a diagram and shade, this time where the sum is more than 8. I'm going to use the same diagram here, and I'm just going to shade. So more than 8 would be 9 or higher, so 6 and 3, 5 and 4, 4 and 5, and 3 and 6. Okay, so it's those. And if I count, that makes 4, 5, 6, 7, 8, 9, 10, 10 squares. Again, all with equal probability. So part B, what is the probability that both dice show the same number if the sum is more than 8? So I'm looking at only those 10. So if I'm looking at only those 10 and they have equal probability, 10 is my denominator because those are the ones I'm looking at. And of those 10 I'm looking at, how many have the same number? Well, the same number is 5 and 5 or 6 and 6, so that makes 2. So 2/10 simplifies to 1/5, and that's for part B. So then C, same idea. I'm again only if it says if you know the sum is more than 8, so only those 10 am I looking at that all have equal probabilities, and then I'm looking for the probability that exactly 1/6 is showing. There's 6 spots, 1, 2, 3, 4, 5, 6, not 6, 6 because that would be 2 6s. So 6 out of 10 simplifies to 3/5. And D, again, out of the 10, because it says, what is the probability that at least 1 5 is showing if you know the sum is more than 8? So the sum is more than 8, meaning just the shaded ones, those 10 that all have equal probability. And I'm looking for at least 1 5 is showing. Well, at least 1 5 means 1 or more. So 1, 2, 3, 4, 5, 5 out of those 10, which makes 1/2. Now, notice because those were all same probabilities, we were able to just use logic and counting. We didn't have to use any formula. But in a minute here, when we look at some where the probabilities are not equal, we're going to have to use a formula. So let's move on to number 3, which is talking about a spinner. So we have a spinner which comes up blue, red, green with a probability of a third for each color, and we're supposed to sketch an area diagram for spinning twice. So I'm going to make my area diagram. And I'm going to try and divide that into thirds. So I have probability of, I'm just going to put the colors here. We have blue, red, and green. Now, if these had different probabilities, I would be taking more time to make this, to fill in all the probabilities. But these are all 1/3. So I know that all of these inside are going to be 1/9. So I'm not going to fill all those in, but that's what they would be. So now I'm supposed to shade where the where we get the same color twice. Well, that would be blue, blue, that would be red, red, and that would be green, green. Well, again, all those probabilities are 1/9. So part B says, what is the probability that both spins give the same color? Well, that's either the blue, blue, or the red, red, or the green, green. Or means we add those. So I'm going to take 1/9 and I'm going to add it to 1/9 and I'm going to add it to 1/9, which gives me 3/9, which simplifies to 1/3. So the probability of getting the same color twice is 1/3. Part C, if you know you got the same color twice, what is the probability the color was blue? Again, these are nice and even probabilities. So I can just say, well, there's only 3 spots that all have equal probabilities, and only one of those is the blue-blue color combination. So that's 1 out of 3. The probability of getting blue, blue, if you know you got the same color twice, is 1/3. Okay, now, I did give some notes at this point on what's called conditional probability. And with conditional probability, you use that probability when you have questions that are worded something like, if you know that something, find the probability of something, or given this, find the probability of this. So look for that keywording. Given this, find the probability of this, or if you know this, find the probability of this, or find the probability of this if you know that this already happened. All of those would be indications that we're going to use the conditional formula. So here's what the formula says. It says the probability of A given B. Now notice when I read that slash, I said given. That slash means given. A is the event that we know, or I'm sorry, it's the event that we want, and B is the event that we know. Okay, so the formula says to figure out the probability of some event given some event you know, you want to put the probability of the event you know, which is B, in the denominator. And in the numerator, you want the intersection of both events. So that'll usually be one spot on your diagram. So you just go to that spot where the two events intersect and then copy that probability as the numerator. Again, the denominator is the probability of the event that's given or that you know. So that's our formula. So again, we didn't have to use the formula on any of these, but if you look back on the way these questions are worded, all of these, part 2, B, C, and D, and 3, C, they all say, if you know this, find this. So realize we could use the formula on all of those. So I'm going to go back now. And I'm going to just show how the formula would work on part C of number 3 that we just finished. So the question says, if you know you got the same color twice, what's the probability the color was blue? So in other words, what I'm looking for is the probability of blue given same color twice. And I know that's what I'm looking for because the same color twice is what I know, and I'm supposed to figure out what the probability is that it's blue. So using the formula, in the denominator, I'm going to go ahead and put my given, which is the same color twice. Well, we had said in the step above in part B that the probability of the same color twice was 1/3 because we took the 1/9, we added it to the 1/9 and the 1/9. So the given is the probability of the same color twice, which is 1/3. The numerator is going to be, again, using this formula, it says the intersection of both events. So my events are blue and same color twice, meaning I want to go to same color twice and I want to go to that color being blue. So that's the blue section. And all I do is take that 1/9 that I already filled in my diagram and I put that as my numerator. So blue and same color twice is the numerator. And the same color twice, which is the given, is the denominator. So we know to divide fractions, we're going to multiply by the reciprocal of the denominator, so times 3/1, which gives me 3/9, which simplifies to 1/3. So using the formula, I got 1/3 for this conditional probability, but also just using logic and thinking there were 3 blocks and one of those 3 was the blue block. That's why the probability was 1/3. Now, again, that worked there using logic because these were equal probabilities. When we look at one here in a moment that has different probabilities, we're going to have to use the formula. Okay, so that's why I wanted to show you how the formula works. Okay, so that takes care of all of page 15. So now let's take a look at page 16. We're going to do the first problem on the top of page 16, which is problem number 4. So we have a spinner that comes up red 25% of the time, green 25% of the time, and the rest is blue. So hopefully you realize that's going to be 50% of the time. Draw an area diagram for spinning twice. So our definites or our events are spin 1 and spin 2. And our choices are the colors, red, green, or blue. So I'm going to go ahead and make my diagram. And I'm going to try to divide that up accordingly. And let's use simplified fractions here. So 1/4, 1/4, and 1/2. So I'm going to go about halfway here. And then about a quarter of the way, half, and then about 1/4 more. So I'm going to go ahead and put my colors here. So we have 1/4 and 1/4 is red and green. So probability of green is 1/4, and the probability of red is 1/4, and then the 50% of the time is blue, so that's the probability of blue is 1/2. So same thing for the other spin. And then I'm just going to multiply. So 1/4 is here, 1/8 and 1/8, 1/8 again, 1/16, and again, and 1/8, and 1/16, and 1/16. So there's my diagram. I'm supposed to shade where we have the same color twice. That would be here, oops, or here, or here. So then I'm supposed to say what's the probability that both spins give the same color. So I know that that's here, blue, blue, or red, red, or green, green. So I'm going to take those probabilities 1/4, 1/16, and 1/16, and I'm of course going to add those because or means we add, and these are mutually exclusive, so I don't have to worry about any overlap. So I'm going to get a common denominator here. I know that's 4/16 plus 1/16 plus 1/16, which gives me 6/16, which simplifies to 3/8. So that's my answer for B. So then C, if you know, keywords there, that sounds like conditional to me, that you got the same color twice, what's the probability the color was blue? So once again, I'm looking for the probability of blue given same color twice. So we are going to use our formula definitely here because we don't have equal probability. So I can't just say 1 out of 3 this time. So what I am going to do though, I'm going to put the given in the denominator, and the given is the same color twice. Same color twice is what we just figured out, 3/8. So that's my given, which means it goes in the denominator. Numerator is the intersection of both events. Well, both events are blue and same color twice. So I'm going to the same color twice, and specifically I want that color to be blue. So that's the intersection of blue and blue, which has a probability of 1/4. So 1/4 is my numerator. So I have 1/4 divided by 3/8, which I know is 1/4 times 8/3. I'm going to simplify on the diagonal here, which gives me 2/3. 2/3 is the probability of blue given the same color twice, which is part C. Okay, and that's about as far as we got in class. I did ask students to do number 5 at the very end of class and then finish that up for homework. So please do problem number 5 on page 16 for homework. And then after that, I'd like you to try the problems on pages 17 and 18. All except for part C of number 3 on page 18. You can skip that one for now, but all of the rest of the problems on pages 17 and 18. So 17 and 18, and finish up page 16, that very last problem. And next week you have a quiz coming up on Wednesday.